No matter what data systems you've got, no matter how good they are, sooner or later, someone's going to ask you to take the data out of it and stick it into a spreadsheet for them. So that's what we're going to do today. We're going to do a coding video where we take some data from Apache Kafka, use Python to do some stream processing on it, and stick it into a Google Sheet for presumably a very happy person in marketing or the finance department or whatever. And I'll show you the data we're going to use. So if I take a look using KCAT at my topic called Weather Data Demo, which if you've seen previous episodes of this series, you'll know is full of weather data from London. It's all JSON blobs, there's loads of it, and we're going to get that into a spreadsheet. The problem with getting it into a spreadsheet is there are thousands and thousands of rows, and that number is only growing. It's going to blow the limits of Google Sheets eventually. So we're going to do some pre-processing on it. We're going to summarize it beforehand, and that's going to make it a bit more manageable and, frankly, more interesting. So let's start. Let's start by creating a directory called weather to Google and go into it. I will do Python 3 -mvm and create myself a virtual environment to isolate my packages. And source env bin activate to activate it. And then I'm going to need two libraries for this, two non-built-in libraries. One is Quick Streams, which is my all-purpose Python Kafka processing library. And the other for the Python to Google Spreadsheets thing is called PyGSheets, which I have decided is pronounced PyGSheets, could be Pig Sheets, don't know. Okay, let's create a main file. If you've watched a few of the videos in this series, you might want to skip ahead one chapter marker as I set up the scaffolding for this. But assuming you're still with me, I always start off my Python programs like this. I imagine pretty much everyone does some variant of this. Yeah, I should probably put this on. Actually, I'll let you into a secret, right? That's my default scaffolding for all Python stuff. I do actually have that as a snippet here. I could have done that automatically. It just always feels like cheating in coding videos when you use snippet engines. I don't know. So I type it out by hand, but in reality, I always do this and I do it automatically. Okay. Next, we need to create a Quick Streams application. So let me import that. Application is the top level object for this library. I don't think there's anything you can do that doesn't involve creating an application first. Maybe there's a counterpoint, but generally you start off by doing this. And we're going to need to specify 4 parameters to get connected to Kafka and up and running. The first, unsurprisingly, is where do you find Kafka on your network? And if you're running it locally in development like me, it's probably localhost 9092. The second, I always set the log level to debug. The third is you want to uniquely identify yourself to Kafka using a unique string called the consumer group. This does things like persistent tracking through the topic, load balancing, and other stuff. We have a video that talks about it more if you want to find a link to that in the description. But for now, any unique string will do. And one thing I often do in development, especially when I'm doing stateful stream processing, is in order to guarantee a completely fresh, unique session, is I use a UUID. You almost certainly don't want to do this in production, but in development, it's handy. So from UUID, import UUID4. And that will just guarantee that we have a completely unique connection every time. And you want to cast that as a string. And the last thing you want to do is say, when I connect to a new topic, do you want to start at the oldest data or the newest data? Do you want to go back and process history, or do you just want to start at what's coming in right now? I want to go back and process history for this one, so I am going to request that we start from the earliest available message using the incredibly memorable named parameter auto offset reset. It's called that, we must live with it. I don't think anyone feels great about that decision. Oh well. Right, that is how you get connected to Kafka. So the next thing is to set up some kind of stream processing app. I've already shown you that my data is in a topic called Weather Data Demo. So let's turn that into a topic object. And I'll call that my input topic. And then I'm going to call the data frame API with that input topic. If you've ever used NumPy or Pandas, this is designed to look familiar to that. It's a pretty straightforward API, and it returns what we call a streaming data frame, which again is a lot like a Pandas data frame. It's a bit different because streaming isn't quite the same, but it'll be familiar, and it's easy to use. And the way pretty much every quick streaming application looks from here on in is you take your SDF and you do something interesting with it, with some arguments. And that returns a new SDF. And then you just keep doing that several times, building up a pipeline of interesting things and getting the next step until eventually you're ready to call app.run on it. And yeah, that's it. All we have to do is something interesting, and that'll make the video good. So what are we going to do? How are we going to make this work? What we need to do, we've got thousands of rows and we want to batch them up a bit. So the first thing I'm going to do is say group them into hourly batches somehow. This is pseudocode at this point, but this is what it's going to look like. Having grouped it into hourly batches, we're going to summarize that hour, right? And then we're going to send to Google Sheets. That's the shape of the application. Now we just need to fill in these things with real function calls. So I'm going to comment those out and leave them around as a reminder of what we're trying to achieve, and look at this first one. So in order to group into hourly batches, you need a windowing function. Time windows, chopping time up into discrete bits. And in my case, what I'd like to do is say a block of 1 a.m., 2 a.m., 3 a.m., 4 a.m., discrete blocks of time of a fixed size with no overlaps. For that, we want what's called a tumbling window. That's exactly what it is. It's discrete blocks of time that don't overlap. And you can pass to that a duration in milliseconds, which in my case will be 1,000 milliseconds in a second, 60 seconds in a minute, 60 minutes in an hour. I could do it like that. I'm not going to. I don't like doing that. I don't find it maintainable. So I'm going to say from date time import time delta. And I'm going to create a time delta object with hours set to 1. I just find that much more maintainable than using multiplied numbers. And if I want to change it to 6 hours, it's easy. If I want to change it to 30 minutes, that works. It's great. Nice API. Okay, that gives me an hour-long block of data. How do I reduce that into a single block for the hour? Well, the clue is in the question. I'm going to call sdf.reduce to reduce my hour's worth of data to a single summary row. And the way this works, it uses a pattern that you'll see all over the place in programming. It's there everywhere in functional programming. You'll see it in virtual DOM stuff. You'll see it in state machines. You'll see it in the actor model. It's all about creating a starting point and then adding in one more thing. And the way that plays out in this API is you want one function which, given the first message for the hour, returns a summary from that. And then another function that says, given that summary so far and one new message, how does the summary change? That plays out with two functions called initializer. I'm going to be imaginative and call that my initializer function. And then there's a reducer. And again, let's call that a reducer function. Okay. So let's define these up here. We will start with the initializer function. That's the one that gets a single message from the very start of the hour and has to turn it into a summary. So we best remind ourselves of the shape of the data, because I've forgotten. Let's say kcat ct consume from the topic weather data demo and have a look at what we've got. This is a JSON object which Quick Streams is automatically going to convert into a Python dictionary. And it has a key under it called current. And under that is a key called the temperature at an altitude of 2 meters, which, if you're wondering what 2 meters is, it's approximately the height if someone's giving you a piggyback. That's roughly the height you'll be at. A scientific term. So the temperature is the message current temperature at 2 meters. How do we summarize that, and what kind of summary do we want? I think it would be interesting to do open, high, low, close. So the opening value for the hour, the closing value for the hour, the maximum and minimum. And if you've done any work in finance or like financial charts, this should be particularly interesting because you almost always want to know open, high, low, close for money, but we're going to do it for temperature. So my summary object, I think, is going to look like this. The opening value is, well, we're dealing with the first message for the hour, so that must be that, right? The opening temperature is definitely going to be the temperature from this message. The closing temperature, as far as we know, it's the same. The only evidence we have is that we've got one message in this hour. And actually, the highest we've seen is that, and the lowest we've seen is that. So traditionally, open, high, low, close. Let me get that in the right order. That's easy. Starting states usually are. It's the reducer that's a little bit more fun. This is the one that's going to take my summary so far and a new message and have to return a new summary. Maybe I should use the terminology that people tend to. So they tend to call it an aggregate. Now I'm going to call it summary. It's arbitrary, and I think that's what we're talking about. So summary object, but you may see it called aggregate sometimes. How do you create a new summary? I think the first thing we should do is get the new temperature out of the new message. And then we want to return the opening value. That can't change. Once it's set once, the opening won't change. So the opening value will be the summary's opening value. All right. The close must be what this latest message tells us. So it's always going to be the last value we saw, the close. The high is going to be the maximum of the highest we've seen and the new temperature, right? So the new high is either the highest we've seen so far or the new temperature if that happened to be higher. Same rule for the low, just in the other direction, okay? And I've missed out some commas, so that's not going to work. So that's a reducer function. That pair of functions, how do you summarize the first thing? How do you add a new thing into the summary? That should be enough to do it. Yeah, okay. Before we send to Google, I think we ought to see this in action. So I'm going to call sdf.update with a Lambda function that gets the message from that and says logging.debug got message. All right. We'll just do that to inspect before we try and send it to Google. Let's have a look. So let me run that with Python 3 main, and we'll see what we get. Oh, I have to source my virtual environment, and that will not work because I've missed out a function call. And this is a very common gotcha. It's easy to forget. You could almost imagine that I've done that deliberately to show you what it looks like. I'll let you decide what the truth is. Once you're finished with the window processing function calls, you need to finalize the window to get back into the regular data frame API. You just need to call final on it. And that says we're finished windowing. You can now treat that as a regular row. So if I call that, we connect to Kafka, we process a load of old stuff, and this is exactly what I was hoping to see. So we've gone back in time, we've reprocessed all the hours, and we've got a series of hourly summaries that tell you the timestamp at the start of the hour, the timestamp at the end of the hour, and then the value is our summary object of temperatures, open, high, low, and close. And what it's doing now is just sitting there waiting for more data to come in. And it will keep sitting there waiting until the end of the hour, and then it will finish off the processing and start waiting for the next hour's worth of data. And I would expect to get one row out every hour continually as long as I run it for. So good. One row an hour should be about reasonable to stick into a spreadsheet, and we can always adjust that time delta if it proves a bit much. With that, our next job is to connect the data to Google, and that's going to be fun. I'm going to leave out one detail here. I normally like to put all the details in, but I confess I'm going to leave out the part where I create a Google developer account and enable Google Sheets API access and create a developer key. Partly because it's really dull to watch and it's kind of dull to do, and partly because it will reveal too much of my personal information. So I'll put a link to the Google Developer Console in the description. You need to go through that process, and eventually you will get a client secret JSON file, which you stick in the same directory. And I'm not going to show you the contents of that either. You just download it from Google. With that in place, I'll tell you what, just for debugging purposes, why don't we comment out that main function and stick it in here? So we need to import pig sheets, and you say pig sheets authorize. That's going to look for your JSON file in the current directory and give you a Google API handle. With that Google API handle, you're going to open a spreadsheet that you've already created. And I think I created one called, let me have a look. I created one called weather sheet. So I'm going to open my weather sheet, and that will give me the workspace. And why don't we just print that workspace and see what we get? Okay. So let's run that. I've got to do an authorization thing. I'm going to blur that out. So what it's doing is telling me to go to a URL and give access, which I shall do off screen now. That gave me an authorization code, which I will paste in. And I'm going to rerun that code without the personal information being quite so visible. And there we go. There's my spreadsheet that contains 2 sheets. Okay. Let's have a look at the first sheet, or the 0th sheet, actually, and see what that looks like. Sheet 1, excellent name. That is indeed the default name. So with this API, there's loads of stuff you can do, but we're actually only going to need about 2 functions on it. The first one is sheet.update values. That takes a list of lists, so sort of a grid of cells you want to write into, and the top left cell that grid should start in. So let me show you that. If I say A1 as my top left cell, and I give it a list of rows, hello, spreadsheet, yeah, that'll do. I am row 2. You get the idea. Let's put a comma on that, and that should auto-format nicely. Yeah, okay, so if we run that, and then look at our spreadsheet, there we go, look at that, lovely. Let's delete that out, and we'll do something serious. So let me uncomment that main, and move this code we've just written up here. Instead of hello spreadsheet, I am row 2, I'm going to put the column names we want. So we will want the start time, the end time, open, high, low, and close. This will be the headers for the Google spreadsheet. And then send to Google Sheets. That will be a function that we apply to every row coming in this stream. Let's just call it to Google. And we'll define to Google here so that it has access to the sheet object in scope. That's going to get a message, which is actually the summary message. And we will say sheet.insert rows. Starting at row 1, insert the values. We need a cell, so why don't we just call str on that message and see what we've got. Close that bracket, delete that, format it. Let's run it and see what we get. They should put in the headings, and then, yes, okay, Good start. That's my Python object. It has a start timestamp of milliseconds since the epoch. It has an end timestamp, and then inside that value is our summary. Okay, so that's reminded us what the data is. So we just need to say, instead of str message, we should be doing start will be the message's start millisecond since the epoch. That should be end. Then we need to dip into the value to get the open, high, low, and close. Did I close everything up? Formatting. I love auto formatters. Absolutely love them. Used to hate them. Got used to them. Now can't live without them. True story. Okay. One more time with feeling. Let's run that on a clear spreadsheet. Start. Yes, that's it. We've got a live updating spreadsheet with high, low, close values. Go tell someone in your finance department today. They'll be very excited. Okay, let's tidy this up a bit. So let's have a look at the consumer group. If we keep this as a random value every time, then every time we run the app, it's going to fill in the rows from scratch, from the oldest possible message available. That's not ideal. What we want it to do is pick up from where it left off every time. To do that is very easy. We just set the consumer group to a fixed unique string. So how about weather to Google? And then Kafka will take care of tracking our progress for us, which is great. The other thing, just for fun, we have these start and end values as seconds since the epoch. Why don't I show you how to use a Google Spreadsheet formula? So if I say date there, and then I can just put a spreadsheet formula in as a string, and you can say something like equals epoch to date is the Google Spreadsheets function name. On A, it's going to be inserted at row 2, divided by 1,000, because that takes seconds, not milliseconds. So if I've typed that right, clear out the spreadsheet one last time, rerun it in a kind of persistent production mode, and yeah, there we go. That is going back to yesterday when I started gathering data for this video. So we're getting all the historical data. And I think we're done. That will now happily run in the background, inserting one new row every hour on the hour, summarizing my data. Lots of different ways you can use exactly the same pattern. And it only took 93 lines of fairly generously white-spaced code to do it. So I'll put all that code on GitHub, and I'll put a link to that repo in the description below. While you're scrolling down to the description, if you've enjoyed this, please leave a like, consider subscribing for the next episode. And if you end up using quick streams in your own projects, consider putting a star on the GitHub repo, because that would really help us. Feedback is always useful, of course. But for now, we're done. Thanks very much for watching.